Now ask yourself this: in all that vastness, across all that time, where is everybody? Hello and welcome back to the Cosmic Horizons podcast. Today we're diving into what might be the most profound question in all of astronomy, the Fermi Paradox. Last time we explored what might happen if we discovered alien life. But today we're tackling the elephant in the room, or rather, the alien that isn't in the room. If the universe should be teeming with life, then why haven't we found any evidence of it? It was a seemingly ordinary summer day in 1950 when the brilliant physicist Enrico Fermi was having lunch with colleagues at Los Alamos National Laboratory. The conversation drifted to UFOs and extraterrestrial life, as scientific chats sometimes do. And then rather suddenly Fermi asked a deceptively simple question: where is everybody? What he meant was this: given the age and size of our universe, with its hundreds of billions of galaxies, each containing hundreds of billions of stars, and given that many of these stars likely have planets, and given that life arose relatively quickly on Earth, well, the galaxy should be absolutely crawling with alien civilizations. Some of them should have developed interstellar travel millions of years ago, so why haven't we seen any evidence of them? That's the Fermi Paradox in a nutshell. The numbers suggest aliens should be everywhere, but observations suggest they're nowhere to be found. It's a bit like throwing an enormous party, setting out all the food and drinks, sending invitations to millions of people, and then no one shows up. You'd naturally wonder what went wrong, wouldn't you? To understand just how puzzling this is, we need to look at what's called the Drake equation. Don't worry, I won't bore you with the maths, but essentially it's a way of estimating how many communicating civilizations might exist in our galaxy. Even with conservative estimates for things like how often planets form and how often life evolves intelligence, we should expect thousands of technological civilizations in our galaxy alone. And that's where the paradox gets really interesting, because if there are thousands of alien civilizations out there, surely at least one of them would have spread throughout the galaxy by now. Even at relatively slow speeds, a civilization could colonize the entire Milky Way in a few million years, a mere blink in cosmic timescales. So where are they? The first and perhaps most sobering explanation is something called the Great Filter. This idea suggests that somewhere along the path from non-living matter to galaxy-spanning civilization, there's an extremely difficult barrier that almost no species ever overcomes. The terrifying question is, where exactly is this filter? Is it behind us, or is it still ahead? If the Great Filter is behind us, that would mean we've already survived something extraordinarily rare. Perhaps the development of complex cells was the filter. After all, it took nearly 2 billion years for single-celled organisms on Earth to evolve into multicellular life. Or maybe the filter was the evolution of intelligence itself. If that's the case, we might be genuinely special, perhaps even alone, in our corner of the universe. But what if the Great Filter lies ahead of us? What if virtually all intelligent species destroy themselves before reaching the stars? Nuclear war, climate disaster, engineered pandemics, artificial intelligence gone wrong. We can already see several candidates for our own potential downfall. Imagine countless civilizations throughout the galaxy, each one reaching a level of technology similar to ours, and each one falling silent shortly afterward. It's a chilling thought, isn't it? In this scenario, the eerie silence of the cosmos isn't reassuring. It's a graveyard of civilizations that couldn't overcome their own self-destructive tendencies. The Great Filter theory forces us to confront an uncomfortable question. Are we exceptional survivors of an incredibly rare process, Or are we simply haven't reached the filter that dooms almost everyone? The answer has enormous implications for how we should view our future. But perhaps the silence isn't because alien civilizations don't exist or have destroyed themselves. Maybe they're deliberately staying quiet. This brings us to our second explanation, the zoo hypothesis. Imagine you're visiting a wildlife reserve in Kenya. You observe the animals, study them, perhaps even protect them, but you don't interfere with their natural development. You certainly don't walk up to a group of chimps and hand them smartphones or teach them calculus. The zoo hypothesis suggests we might be in a similar situation. Advanced alien civilizations might be aware of us but have chosen not to make contact. Perhaps they're studying us the way we might observe animals in their natural habitat. Or maybe they're waiting for us to reach a certain technological or ethical milestone before welcoming us into a galactic community. There could even be a kind of prime directive at work, a rule against interfering with developing civilizations. Science fiction fans will recognize this concept from Star Trek, but it's actually a reasonable ethical stance. After all, when European explorers contacted isolated human cultures, the results were often catastrophic for the less technologically advanced societies. If the zoo hypothesis is correct, it means the night sky might not be empty at all. We might be surrounded by advanced civilizations, carefully observing our development while remaining hidden from our detection. Every time you look up at the stars, you might actually be being watched. It's a scenario that's simultaneously comforting and unsettling. Comforting because it means we're not alone and potentially protected from certain cosmic threats. Unsettling because, well, how would you feel knowing your every move was being monitored by beings far more advanced than yourself? But what if the silence isn't benevolent? What if it's born of fear? This brings us to perhaps the most chilling solution to the Fermi Paradox, the dark forest theory. The name comes from the science fiction novel The Three-Body Problem by Liu Cixin, but the concept is rooted in game theory. Imagine a dark forest at night. You know there are other hunters in the forest, but you can't see them. You don't know their intentions, their capabilities, or their locations. What's the optimal survival strategy in this situation? The answer is to remain silent and hidden, because any civilization that reveals itself in the cosmos is taking an enormous risk. Think about it. If you detect an alien civilization, you have no way of knowing if they're peaceful or hostile, and by the time you find out, it might be too late. In this scenario, advanced civilizations stay quiet not out of benevolence, but out of self-preservation. They don't broadcast their presence because doing so would be equivalent to shouting in a forest full of predators. And if they detect a civilization foolish enough to announce itself, like, say, humans broadcasting radio signals into space, they might preemptively eliminate the potential threat. It's a profoundly unsettling thought. The silence of the cosmos might not be evidence of our uniqueness or the rarity of life, but rather a testament to the fundamental danger of interstellar communication. Every civilization might be hiding, listening carefully, but never revealing themselves. If the dark forest theory is correct, our active search for extraterrestrial intelligence might be the equivalent of a person lost in a predator-filled jungle shouting at the top of their lungs. Not exactly the wisest survival strategy, is it? Our final explanation takes us in a completely different direction. What if we don't see aliens because they don't exist in the way we imagine? What if our entire universe is a simulation created by an advanced civilization? I know. It sounds like something straight out of The Matrix. But the simulation hypothesis has been seriously proposed by philosophers and scientists, including Oxford philosopher Nick Bostrom. The argument goes like this. If any civilization reaches a post-human stage of development, they would likely have enormous computing power. They might create detailed simulations of their evolutionary history, running many different versions to study how civilizations develop. If that's possible, then simulated universes would vastly outnumber the one real universe. And if there are billions of simulated universes but only one real one, the odds are overwhelming that we're in a simulation rather than base reality. In this scenario, we don't see aliens because they haven't been programmed into our particular simulation. Perhaps the simulation is specifically focused on how a single, intelligent species develops in isolation. Or maybe the computing power required to simulate multiple interacting civilizations would be too great. It's a mind-bending possibility that challenges our very concept of reality. We're living in a simulation, then the stars above us aren't actually distant suns. They're just data points in an unimaginably complex program. And the silence of the cosmos isn't a puzzle to be solved, but simply a parameter of the simulation we inhabit. So where does all this leave us? With 4 possible explanations, each more extraordinary than the last. Either we're incredibly special, having survived a great filter that eliminates almost all life before it reaches our stage, or we're being deliberately quarantined by more advanced civilizations, or we're all hiding from each other in a dangerous cosmic forest, or our entire reality is a simulation. Each possibility fundamentally changes how we should view our place in the universe and our future as a species. If the great filter is behind us, then we're incredibly precious, perhaps the only intelligent life for thousands of light years. That would make our survival as a species all the more important. If the great filter lies ahead, then we need to be extraordinarily careful about existential risks like nuclear war, climate change, or artificial intelligence. If we're in a cosmic zoo or a dark forest, then perhaps we should reconsider our strategy of actively broadcasting our presence to the stars. And if we're in a simulation, well, that raises a host of philosophical questions too complex to address in a single podcast. What fascinates me most about the Fermi Paradox is that it transforms astronomy from a purely physical science into something that touches on biology, sociology, philosophy, and even theology. It forces us to confront not just what we know about the universe, but what it means to be an intelligent species looking out at the cosmos. Personally, I find the Great Filter explanation most compelling, specifically that the filter is the development of complex life or intelligence. The more we learn about how many lucky breaks were required for life on Earth to evolve from single cells to humans, the more I suspect that the universe might indeed be a lonelier place than we'd hope. But the beautiful thing about science is that it's not about what I believe or what you believe, it's about evidence. And as our technology improves, as our telescopes get better, as our methods for detecting biosignatures on distant worlds advance, we may yet find an answer to Fermi's question. And that brings me to our next episode. If we are alone, or at least very rare, in the cosmos, what responsibility does that place on us? What is humanity's potential future among the stars? Could we ourselves become the advanced civilization that seeds life throughout the galaxy? Next time, we'll explore the concept of humanity as a spacefaring civilization and the ethical questions that raises. What right do we have to spread beyond Earth? Should we terraform other worlds? And if we encounter primitive life elsewhere, what obligations do we have toward it? Until then, I'd love to hear your thoughts. Which solution to the Fermi Paradox do you find most convincing? Are we alone, being watched, hiding in a dark forest, or living in a simulation? Leave your comments below and don't forget to subscribe to the Cosmic Horizons channel for more journeys through the greatest mysteries of our universe. Thank you for listening. And remember, every time you look up at the night sky and wonder, where is everybody? You're asking one of the most profound questions in human history.